Okay, so we're on page 247, and this is section, what, I don't know, 2.12 in this book. And so we were working on this one in the previous videos. So again, I can do the algebra distribute, which is 2x plus 2 equals 2x plus 2. And remember, if there's adding anywhere in the problem, that means you're going backwards on the add and subtract scale before you deal with multiplying and divide, because we're doing order of op backwards. And so again, if I bring my yellows to one side or my constants to one side, those go away, and I get 2x equals 2x. And then if I bring my variables to the other side, actually everything ends up going away. So anytime your variables go away, like the previous example we did, something weird's going on. And notice that this is a true statement. So that means that instead of this one we had no solution because it's never going to be balanced, this one is a true thing, which we call an identity. And so this one you're going to get infinite many solutions. Okay, so no matter what I plug in there, it's going to work. And I can draw a picture for this, again, with that whole idea that this is all about balancing, like a teeter-totter. So on the one side, I have what? 2x's, which again, those are our variables, and we have that on both sides. And then on the first one, initially, I know these are going to look the same, but okay, so if we read kind of what that first one said, this is two groups of x plus 1. So if you kind of see, do you see one group of x plus 1 and then another group of x plus 1? But when we distribute it, you can see that that's the same as 2x plus 2. Okay, so you have an x with a 1, another x with a 1, two groups of that. So that's the same as 2x plus 2. And then over here, we started out with that. So notice when I took the 2 away from both sides, trying to get all the yellow on one side, they just all disappeared. And then when I took the x's away from both sides, same thing. But again, notice 0 does balance with 0. So that's a true statement, but it doesn't matter what x is. So if I say, well, x is worth 5, 5, 5, and 5, I get 12 and 12, which is definitely balanced. But if I say, oh, no, x is actually 8, 8, 8, and 8, that's 16, 17, 18, which balances with 18. So it doesn't really matter what x is. It's going to balance no matter what. All right, try number 7, A, B, and C, and then we'll look at these. All right, let's look at this first one here. And, ooh, I didn't mean to cross it off there. Sorry about that. Let's try to get the highlighter. This one right here. Since I have 9 x's over here, I've decided that I want this to be my variable side. So I'm kind of bringing my variable or my blue things or boxes to this side. And then I'm going to move my yellows to the other. Now, again, look at order of op backwards. You always, please excuse multiply and divide are tied left to right, add and subtract. So if there's any adding in this problem, you have to do this, and we got to go backwards. So I want my variables on this side. So let's see, that means I want to get rid of a negative 7x. So I have to use adding to do that because there's adding in the problem. So those cancel, and I get what? 5 equals 9x, 7x is what? 16x plus 24. Now notice, I still have adding in the problem, so I can't move on yet. And my goal, I like having these x's over here, but I want my constants to this side. So to get rid of adding positive 24, again, I have to use add or subtract. I'm going to do a negative or subtract. So those go away. So let's see, what do I owe? 19 here equals 16x. Now, notice at this point, there is absolutely no adding or subtracting left in the problem. So now I'm ready to do the reverse here. So there's multiplying in this problem, so the reverse would be to divide. So x equals a negative 19/16. And actually, we like it improper better. If you're like, I don't really want to check this, well, it's not that hard because you have a calculator that does fractions, or you should. So just type it in, 5 minus 7, and then shove your answer in there. So sub in negative 19/16, and hit enter. And then do the same thing to this side. 9, sub that in, negative 19/16, and then plus 24. And again, to do that, you can use that fraction key like ABC to put your fractions in. Hit enter. And if you get the same number for both of them, you're right. If you don't, they don't. Because remember, just like chemistry, this answer has to balance with that answer. And if it doesn't, then it's wrong. All right, try B and C, and we'll keep moving on. All right, so now we're going to work on this one right here. Now, again, before you want to start really doing order of op backwards, you want to make sure you just have some x's plus or minus whatever, some constants equal to some x's or y's, whatever, plus or minus some constants. So you want to get it as organized as you can before you start doing things. So I'm going to distribute that. So that gives me what? A negative 10x positive 30x, and then what, minus 12? So let me double check. Negative 10x, positive 30x, and negative 12. And then on the other side, what do I have over here? My 20x is fine, but I could combine these. So if I owe 8 and I owe 4, I owe 12 or minus 12. If you can't see that, you could add the opposite. Debt and debt makes more debt. Now, I can simplify this more. So let's see, x's and x's make x's. I have 30, I owe 10, so that's what, 20 minus 12 equals 20x minus 12. Okay, so now I'm actually ready to, start doing order of op backwards. So let's see, there is definitely adding and subtracting in this problem, so that's where we're going to start. I like x's, but when I look at this, I see I have the exact same things on both sides, so that's going to be problematic. If I subtract 20x from both sides, and that's not division, that's just a line. These cancel and I get a negative 12 equals negative 12. If I add 12 to both sides, I get 0 equals 0. So that's a true statement. This is an identity. I'm going to get infinite many solutions because if you can look, these are going to be the exactly same. No matter what I type in for x, they're always going to be balanced. So that's going to be infinite many solutions. All right, pause one more time. If you haven't finished this one yet, do it now, and then we'll come back and talk about it. Okay, so it looks like they've already simplified. They have their kind of x's in a pile, numbers in a pile, x's in number piles. So if I think about, here's my teeter-totter. I have, what, 3 x's over here, x, x, x. 3 x's over here, so that balances. That looks good. And then I have, I owe 2. So, let's see. So here I owe, this is a negative and a negative. So I owe 2. And then over here on this side, I owe 5. And again, I'm going to make my constants yellow here. Okay. So, to solve this, again, there's adding involved. I can see add or subtract, so that means to undo it, I have to use that. So I'm like, maybe I want to bring my x's over, so I subtract 3 x's because they're positive. And these guys cancels in this. So right away, that's a warning because all my x's are going away. So if I take these x's away, these x away, I have no x's left. But then notice, does negative 2, is $2 of debt balanced with $5 debt? And obviously the answer is no. If I try to add, say, 2 to both sides, or take negative 2 away. So if I add 2, I get 0 equals negative 3. So if I add a positive 2 to this side, positive 1, that's going to get rid of that debt. And then if I add, like a positive 1 to this side, that's going to get that rid of debt. So, but this is never true. 0 never equals a negative 3. So this will be no solution, or what we call contradiction. This, if you have the same number of x's, but these constants vary, then that would be impossible. All right, I want to go back and look at that fraction one we skipped. So if you want to turn back to page 244, I'm going to show you kind of a quick and easy way to do fractions. Okay, so one thing I'm going to tell you on this one is if you want to do fractions and you have a calculator that does fractions and they don't bother you, you can do fractions. So for example, I notice I have x's on both sides and there's definitely adding or subtracting in this problem, so I'm kind of undoing that step. And I want my x's all on one side. So I don't really want to bring these x's over and then have to bring my constants over. That seems like double work. So since all I have on my right side is x's, I could just bring them over. So what you could do is subtract half x from both sides. And that would cancel that. And then again, you could do this on your calculator. So you could do 5/8 on your calculator minus 1/2 on your calculator, and it will spit out an answer. And so I don't have a calculator with me, so I'm going to do this by hand. So times 4 times 4. So 5/8 minus 4/8 is 1/8. So I would get 3/2 equals 1/8 x. And then, again, if you like to divide both sides, there's nothing saying, we're done with add and subtract those, so we're moving on to multiply and divide, because do you see how there's no adding left? So again, if you have a calculator that does fractions, you could just be like, well, I'm going to divide by 1/8, divide by 1/8, and let the calculator, just make sure it's in parentheses, but you can let the calculator do the work. Otherwise, if you're like, well, I don't really want to do that, I would just rather multiply myself. Okay, that works too. So to get rid of multiplying by 1/8, you would use the reciprocal. And 8 cancels 8. So you just get a bunch of 1s. So you obviously have 1x left. And then here, 2 goes into itself once, and 4 times 3 is 12, divided by 1 is 12. And so x equals 12. Usually we write like that. But there is another way. So if you think of kind of like a microscope, like if you have this petri dish, you might not be able to see anything in it with the naked eye, okay? But then when you put it under a microscope, what you're doing is you're zooming in, and so suddenly, like I'm looking really close at these things, and I might be able to see some little diseases or some little cells or who knows, some type of mold growing in there, so I could see whatever, okay? But only because I zoomed in. But when I take it out of the microscope, it's still going to look like that. So I'm not really changing anything, I'm just zooming in or zooming out. So if you think of a teeter-totter, kind of the same idea. If I have like half over here and a fourth plus a fourth over here and I have fractions, if I want to, I could just say, well, I'm going to make this everything twice as big, both sides. So suddenly this becomes worth 1. And these guys, if they're twice as big, become a half. But it still is balanced. And so by making things bigger, just like a microscope, it doesn't really change it. It keeps everything balanced. It just looks different. So that's what we're going to try here. So if you hate fractions, what you can do is you can clear them. You can actually get rid of them by just making everything bigger. And how you decide what to make them bigger by is you use the common denominator. Because what that's going to do is clear your fractions. So if I look at this, the common denominator is 8. So what I'm really doing is I am just making everything 8 times bigger. So you can either use a calculator or do this in your head. Half of 8 is 4, and the x is still there. Let's see, 2 goes into 8, 4 times, and you get 12. Or if you don't like that, you could take 3/2 times 8 on your calculator, and you'll still get 12. And then this 8 cancels that 8, and I get 5x. Or again, you could take 5/8 times 8 on your calculator and get that. So notice all I did is I zoomed in so much so that you don't see fractions anymore. And so then now I'm going to bring my x's to one side. And again, since I have no adding over here and I have adding over here, I'm going to use adding or subtracting because I'm still at that stage. There's adding, I can't move on. So I'm going to move that over. So I'm going to subtract 4x to both sides so that the x's are over here. So I get 12 equals x, or x equals 12. And that's called clearing the fraction, which is super nice. Now, to check your answer, again, you're going to want to go back and shove it into this original thing. But again, you have a calculator, so don't make it, you don't have to do it by hand. So you're going to just take half, and you're going to sub in the 12 where the x is, plus 3/2, and hit enter. Okay, and see what kind of answer you get. And then you're going to shove it or sub it into the other half. So you're going to take this 12 and shove it or sub it into there. So you're going to hit 5/8 times, 12, enter. And again, remember, just like the chemistry equations, if the left side and the right side balance, you know you're right. So whatever answer here, if it balances with the answer we get over here, then we know we're right, which in this case it does. So we know that we're good. That's called clearing the fractions, and that's a super good strategy if you're not a big fan of fractions.